So, did the professor say anything about the midterm? Like what it will cover? Or at least cover up to? No one? Okay. Yeah, I feel like I don't really want to go over new content that much because everyone's probably focusing on the mid. So I'll just quickly go over the main theorem and then maybe like one exercise, and then I'll leave the rest for like midterm prep questions, I guess. So let's get started. So we have the Weierstrass approximation theorem. So basically it's saying every continuous function on a closed interval AB can be uniformly approximated by polynomials. Formally approximated by polynomials on AB. So basically what that means is there exists a sequence Pn, sequence of polynomials Pn of x, right, that converge to f of x uniformly. Right, so this is pretty big, right? So note that the closed interval assumption is needed. I think part of the main fact is that we have that special nice property that continuous functions on closed intervals are uniformly continuous, right? So, and the proof, I guess, the proof of it uses that, like the, continuous function on closed intervals are uniformly continuous. At least I think, if I recall correctly. And it uses Bernstein polynomials. So these are just special polynomials that approximate f. So yeah, I don't think you need to know the proof, but at least know what Bernstein polynomials are. Okay, so let me just say this is not really that, surprising, right? Because if you recall, like e to the x on R, right? Forget AB. It was sort of like, it was given by like a power series, right? So, I mean, a power series is kind of like a polynomial, right? Except it's, infinite degree. So your question is, okay, so basically you could say, okay, if I cut it off at some point, it should approximate e to the x, right? But like when I cut it off, it's going to be a polynomial, right? So that's sort of, the intuition, right? If you restrict to a closed interval, you could sort of, find polynomials that approximate it. Like e to the x is just, you could think of it like cutting off the power series, right? At some point for like large enough, right? So, but note that closed interval AB in assumption of theorem is needed. So I'll just do that one question where it's sort of, kind of tells you what goes wrong. So so this is the Weierstrass section. So let's do 27.3, right? So here show there doesn't exist a sequence of polynomials converging uniformly on R to F if F is sine X. So here, like the interval AB is, we're not in the interval like A to B right here, right? So basically we're gonna see, okay, on R it fails. So I'll just do this example and then leave the rest of the section for questions. Okay, so show there does not exist sequence of polynomials Pn of x going to f of x equals sine x uniformly on R. So before we do this, let me just tell you the idea, and then we'll sort of go over the proof next time. It's not that hard, but I'll let you think about it. So if I give you a polynomial, let's say, I don't know, AK. Let me just say this. So if I gave you a polynomial, I don't want to use P to confuse you, so let's use Q. Is AKX to the K all the way to A1X plus A0, right? Let's assume K is bigger than or equal to 1, right? So it's not constant. And let's assume AK is positive, yeah? So without loss of generality, we could assume AK is not 0, right? It's either positive or negative. Because if it was 0, I would have just wrote AK minus 1 x to the K minus 1. So can anyone tell me what happens? How does this polynomial behave when x goes to infinity? Anyone? Just check something. Oh, okay. So anyone know how polynomials behave, right? So I mean, for example, like x squared plus x plus 1. How does how does this function behave when x goes to infinity, right? So you see that this thing goes to infinity as x goes to infinity, right? And really, if I put minus here, it doesn't change anything, right? We look at like the leading term, right? When we determine when x goes to infinity, which is why I asked here that this is the leading term, right? So we know that q of x goes to infinity as x goes to infinity, right? Because when x goes to infinity, like the highest degree dominates. Okay, so now we have that. Now comes the question, right? Like f of x, like f of x equals sine x is bounded, right? Is, let me just say, sorry, less than or equal to 1. We have this, right? So I'll let you think about it, but if I have a sequence of polynomials converging to sine uniformly, right? And sine is bounded, but my polynomials are going off to infinity when x goes to infinity. That's a problem, right? You could show it doesn't converge. It doesn't even converge, right? Because you're like on one point, f is like, f is like right here, right? I mean, f is in this interval, and then your polynomials are like going off to infinity, right? And similarly, if ak less than 0, q of x goes off to negative infinity, right? Right, you're either going off here or you're going off this way, right? So basically, you're going to get that, you know, AK must be 0. If AK is not 0, you're like, you're not going to converge uniformly. And if you do this inductively, you're going to get that Q of X must be constant. Right? So Pn of X, like, basically must be sequence of constant polynomials. Because if they were not, I mean, once you have a linear term, right? Like here, I assume that K was bigger than or equal to 1. So here, basically, I'm assuming it's at least degree 1. And once you're degree 1, you're going to go off to either infinity or negative infinity when x goes to infinity, right? So here, you get that you must be constant. But then it's easy now, because you can't really approximate sine with just constant functions, right? It's sort of impossible. You could show by contradiction that this can't happen. Because if you're here, if Pn, like for example, if Pn was here, right, it's some constant number. So let's say for n bigger than n, let's say capital N, it was this constant function. You are not epsilon away from like this point, right? Like once epsilon is like, you know, here, this is really far, right? So yeah, so that's basically the idea for sine x. And for e to the x, you look at x goes to negative infinity. So here again, the exponential, when x goes to, it's bounded by 1 here, right? The exponential when x goes to negative infinity. So what's going to happen is, again, you're going to get that it's bounded from 0 to 1. So less than or equal to 0. But you know, your polynomials go off to either, again, when you go to negative infinity, you either go off to positive infinity or negative infinity. So it's the same argument. You're going to get your polynomials are constant, but if you're constant, you are not going to approximate e to the x, because e to the x goes off to infinity on, you know, the other side. So, and if you try to catch up, right, then you're far away from like the bottom, right? So okay, so that's like picture proof. I don't really want to do any hardcore proofs today. So everyone clear on like, so this is the reason I can consider x going to infinity was because we considered all of R, right? This certainly won't happen for like unclosed intervals, because we have this theorem, right? So yeah, so you can see what goes wrong when you consider all of R. And the idea is polynomials, they either go off to infinity or negative infinity. And that is a huge issue. Okay, so I'm gonna stop here and leave the rest of the section for midterm questions. So anyone? It would be helpful if someone can tell me like what the professor said about the midterm.
I think he said only up to section 27. I'm not sure though.
Because I feel this Weiestrass thing is fairly new, right? I don't think he'll test
Yeah,
on
he
it.
said not to worry about it that much. So
Yeah. So another reason why I decided to stop early. I don't think people really care about new topics like before the midterm. Yeah, so I guess it should be everything up to integrating and differentiating power series, I guess. Yeah. Okay. So I'll leave the rest for any questions. It could be homework too, if you. Although I don't think he assigned new homework, so.
I have a question on the Weierstrass M test.
Oh, okay.
So is it an if and only if? So like can we use it backwards if we wanted to?
What do you mean? So,
Like if a if a series of functions is uniformly convergent, then we
uh-huh.
can say that there exists an MK um
Oh, that is clear because
yeah,
if
right?
if some an x to the n converges uniformly on like negative r to r, right? Then
Uh-huh.
then I mean then you could choose like r1 in negative r to r. It converges uniformly here, right?
Uh-huh.
And you I mean like you certainly I okay I guess it sort of like depends what your uh yeah, it sort of depends what your an is, I guess, but like you know it can it's certainly like this, right? It's certainly if this thing's always positive, then like you're certainly you know smaller than or equal to this thing on say like negative r1 to r1, right?
Mm-hmm.
If yeah if let me say this, if an is always positive, yeah,
Okay, thank you.
right, you certainly have this. I don't think the converse is really useful. You normally go the other way because no I mean if we knew a function converge uniformly that I mean like there's that's already really nice, right? We
Yeah.
the question normally will normally ask prove something converges uniformly. Yeah. Yeah. By the way, I guess you could just put absolute values here. If a is not positive, then you just absolute value it. Did everyone take the quiz yet? Hopefully, it's a good refresher. I put like the two main things on it, like the uniform continuity and uniform convergence.
Oh, hello. I had a question from one of the, I think it was the previous quiz.
Okay.
I think one of the questions was like some infinite series with x, then like sine of x, sine of like nx or cosine of 3x, and it asked like, does it diverge or does it not converge? Does it converge pointwise or does it converge uniformly?
Okay,
Is
maybe it was just n, right, or something like this. I don't know.
it had like 100 n's, yeah, 100 on the bottom, like 100 n
Sure,
square, and then like
sure.
x on the top, like x to the some power. And I was just wondering, for
Well,
that
what happened?
one, were we supposed to use the there was like one theorem, I think it was the one that another student asked.
Yeah, you use Weiestrass test.
Okay, and you say it's like less than some.
I don't know. Do you have to ask the whole question or?
No, I sorry, it's the quiz is muted, so I'm not sure if we can
Quiz
go
is
back
muted.
or like the quiz score, or I can't go back and look at the questions.
Oh,
I
really?
think. Yeah.
That should be possible. Let me see.
I'll check it
Oh,
again.
I hate this. Give me a moment. I have to do the duo code.
Oh. Oh yeah, it says the quiz 5 is muted.
Oh, that is weird. No, that's not what I want. So quiz 5, right?
Yeah.
Preview 2. No.
It was question 3.
Oh, I see. Yeah. So on -4 to 4. Okay, that makes more sense. So let me just copy that. So 3n and n to the 5th. Okay. So okay, so this thing, and then sine of nx, and then times x to the 4th, I think. And then there was like a n to the 5th here. Yeah, 100. Okay. This, right?
Yeah.
I asked, does this thing converge uniformly on -4 to 4, right?
Mhm.
Okay, yeah, it is just the m test, because here you have that this thing is bounded. Let me just ignore the series for now. The absolute value of this thing is bounded by what?
X to the 4th divided by 100 n to the 5th.
It's even what do you call it? Better. What is x to the 4th bounded by?
Oh, 4 to the 4th.
Good. Right. So
Yeah.
this is your mn for your. I think it's state the node mn for your Weierstrass m test, and we know that the sum. I don't care what this 4 to the 4th over 100 is, but I know this thing converges.
Okay.
Yeah.
All right. Thank you.
Yeah. The cosine and sine, it doesn't really matter. You just bound it by 1. They just go away.
All right. Thank you.
Okay. Yeah, I don't know why. So none of you can view this. Let me see. Wait, can you view your own quiz? Like
It says when I'm looking at my quiz 5, it says your quiz has been muted and the score is unavailable because the instructor has not finished grading.
Oh, that's weird. Okay, I'll try to figure that out later.
All right. Thank you.
Hi, can you hear me?
Yes.
Yeah,
Yeah.
I have a questions for like the ratio test and there's a root test, right? There's a two tests, and to find the converge integral. So basically, sometimes the ratio test will be same as the root test, right?
I mean, if they both agree, then I mean, if they both like have a result, then then yeah, it should be the same.
Okay, so if they both have the result, they will be the same.
Yeah.
Okay.
The radius of convergence is unique. It should be a set number. It shouldn't change.
Okay. Yeah, I got it. Okay, thank
But
you.
but it is possible for like radius of the ratio test to fail, and then root test to give you what you want.
Okay.
Yeah.
All right, thank you.
And by fail, I mean like inconclusive. One, two, three.
So for our midterm, like, so for our midterm, it's only like 50 minutes, right?
I think so, right?
And how many questions we have?
Oh, I didn't make the midterm, so I don't know. Your professor made the whole
Okay.
thing. Yeah. I mean, if it's only 50 minutes, I don't think he could put that many questions.
Okay.
Did he tell you how it works? Like, is it like my on Canvas quiz, or like do you upload PDF, or like what?
I think it's the lockdown. We use the lockdown browser, something like that.
Oh, I see this thing.
I
Okay.
think he said something about a PDF. I'm not sure though. So I don't really know though.
Yeah, see, even I don't have access. Yeah.
When I talked with him during office hours, I think he was saying he was probably not going to use like something like Respondus. He'll probably make it like a PDF.
Like PDF up, kind of like the first quiz or something, I guess.
Yeah, I think it's something like yeah, like that.
Yeah, I guess you have to make sure, like, because like the reason I made mine have such a large time interval was for like people who like tech issues, I guess. So I guess for this you have to make sure like there's no tech issues.
Yeah, that's
Since
my biggest fear about the taking the midterm is uh, not just being able to upload it fast enough.
yeah. So weird. Oh. Or is this it? Okay, so I just hit let students see their quiz responses. So if anyone can check now, at least quiz 5, and tell me, do you, if you could see your quiz, I guess.
Yeah, I actually forgot to do the quiz 5. It's okay to see what is the quiz 5 is.
Oh, you mean like all the questions?
Yeah, because I forgot to
Oh,
take the quiz. Yeah.
okay, so this is the first one.
All right. No, no, I mean, can I go to the comments to see? Because you may, I think you made the quiz. So.
Hold on. Still muted. So is this only quiz 5, or like, what about like quiz 4? Are they all muted?
I could see quiz 3.
You can see quiz 3. Yeah, see, I sort of made quiz 5 like quiz 3, right? So I think it's that airplane. If you see the airplane icon next to quiz 3, that's sort of like the different one. I'm pretty sure it's just what just happened. Let students see. Students should be able to see this. Oh, that's pretty weird. Oh no, it shouldn't be the plane. The plane is like on it means like on canvas. Hmm. That's pretty weird. Yeah, I'm not sure right now. Um, mm, yeah, I'll have to see, or maybe you could tell the professor, and then maybe he knows how to open things up, I guess. Wait, what about the ones you uploaded? Can you see those? Like not the on-canvas ones, but the ones like that you upload.
Yeah, we can see that.
Oh,
I
okay.
think we can show the feedback also.
Oh, okay. Makes it seem on that there's time left. Well, it's supposed to be 11:59 p.m., but they don't let me do 11:59. So, oh, sorry. It should be 12. Like it should be like exactly 12, but they don't let me do exactly 12. So like I just add a minute. I mean, do you want me to subtract a minute or uh, um, can I chat to people? Oh, yeah. Okay. Yeah. Let me just stop share really quick. Oh, I see. Okay, so basically you're saying like because you see that it's like tomorrow, you think that there's plenty of time left. Okay. Uh, do you want me to change it to 11:59? I mean,
All I'm saying is just if it's not a problem, because of the fact that you have the Canvas scheduling and it stacks like with a bunch of other classes,
I
and
see.
yeah, if you have like if it says Thursday and it's like oh Thursday along with all the other quizzes that I have and the homeworks due, it's like
I
it goes past. Like I just if it's not
I could,
too much.
yeah, I could probably make yours 11:59 if you want.
If it's, I mean, I don't mind. It's just Canvas is really annoying in the scheduling part, like on the to do thing,
I
especially when
see.
you're taking a lot of classes. Like I feel like there's a lot. And just it's a
Okay.
weird organization to say it's due at 12:01 because then you get notifications saying it's due Thursday. But I didn't want to sound like a complainer. But yeah, if you want to keep it that way, it's fine.
No, I think I actually have the option of like setting like quiz times for a specific person. So if you really want it at 11:59,
That kind
you
of
could do
seems like too much. I'll be honest with you. It's fine. It's fine.
that. Okay.
Actually, I had a question just in general. Has anyone ever used the Respondus lockdown? Because from my understanding, you're not allowed to do like a PDF upload, right? So if the professor's going to go with PDF upload, then it's going to be not on Respondus for sure.
Yeah, I mean, what is Respondus is sort of like a AI like cheating check for cheating system or something like that, right? So like, I mean,
In office hours this morning, the professor said he wasn't going to do respondus.
Okay, thanks.
Yeah.
yeah, but I feel I guess Respondus is like the sort of like the best way in terms of like proctoring, I guess.
Did the professor say how long we would have to like do the midterm and upload it, or he just said it wasn't going to be on Respondus?
I think he said it's going to be like normal 50 minutes. He's going to make the questions so they're not like they're not online anywhere. He's just going to personalize them as much as possible.
Oh, okay.
Yeah.
Thanks.
So is it like 50 minutes and then he gives you like 10 minutes to like upload or something like that? Or
Oh yeah, actually he didn't address the extra upload time. Maybe ask him about that. I'm not sure. Yeah.
I see. Not to like, tell you all to flood his email, but like, if something's not working, just worst case scenario, like just email him.
Yeah, I had another professor who did like the no respondus, and we just had to email him and all the TAs. Would we just be able to email you as well, the final, just in case?
I prefer you email him.
Like
But
both, just in case.
oh yeah, I guess. But like, see, the thing is, once I do that, like, I feel like I'm pretty sure he doesn't want his email flooded, So,
I
like,
see.
if everyone starts doing that, yeah. Yeah, so certainly, but I'm just saying, like, do that as like a last resort, right? I mean, you don't want to get a 0 on your midterm. So, like, I mean, like, if tech issues actually come up,
Like if Canvas isn't working, I see.
or like if you lose internet, then maybe just use your phone data and just email him or something.
Okay.
Yeah. Yeah, maybe someone email him about the quiz too, like the fact you can't see it, the quiz 3 and 5. Uh, yeah, my guess is he's just gonna a Sorry, I think my screen froze. And now there's two of me. Interesting.